Good evening, sir. Thank you, sir. Shall we start? Yeah. Good evening, everyone.
Good evening, ma'am.
Good evening, Soumya ma'am. So, shall we start?
Yes, ma'am.
Yes. Good evening, Sujitha ma'am.
Good evening, ma'am.
Good evening, ma'am. So, I think it's day.
Good evening, madam.
Sorry. Good evening, so much. Good evening, sir. So, I think today I'm going to talk about, means from today itself, we are starting with the hypothesis testing using the R. Fine. So for the purpose, I've shared with all, or I have shared with all of you sheet on the WhatsApp group. I hope you people have seen the sheet. Yes.
Yes, ma'am.
Yes, Kavita ma'am. Fine. So I'll share my screen, and we will talk about the hypothesis testing using the R. Give me a second. My screen is visible?
Yes, ma'am.
Yeah. So it's day 6. I'll start with hypothesis. Anyone who can tell me what do you understand by term hypothesis?
It is an assumption.
Yes, very correct. It's an assumption or tentative statement which we need to test using data, right? This is hypothesis, right? Hypothesis means which is a imaginary thing, or maybe from the environment or the surroundings we have observed something, and we have converted that into the statement form. We will be having the variables in the hypothesis, and using the collected data for the variables, we want to test that particular hypothesis. That is hypothesis, right? Usually, there are two types of hypothesis, null and alternative. Generally, H0 or H0 we are saying, and HA or H1. Right? So, when we say null hypothesis means what?
Ma'am, there is no significant difference. Suppose if we have one sample, then parameter and statistics, there will be no difference.
Yes, very correct. So means we can say this thing when we are saying the null hypothesis. So null hypothesis meaning is generally null means void, right? That means nothing like this exists, right? Or we can say generally we are writing the null hypothesis like there is no kind of thing, right? So always we are testing the null hypothesis, right? So if your data not supporting your null hypothesis, in that case, we are accepting the null hypothesis, and it will be opposite to null. That is, there is a significant, right? So this is the basic thing about the hypothesis. Apart from that, there is one more term, that is level of significance. Anyone who can tell me what is this? Anyone? Level of significance?
5%, ma'am.
Okay, fine. So it can be 1% generally, 5%, or 10%. Usually these are the percentages which we are using in case of level of significance, but mostly used is 5%. So the meaning of level of significance is it is the percent of error, percent of committing the error, and generally this error is known as type 1 error. So if we are saying 5% is, we are representing this, just a minute, I'm writing here. We are representing this by alpha, right? So if we are saying alpha is 5%, that means chances of committing error is 5%, right? That means type 1 error says reject the H0 when it is true. So 5% chances are that when the null hypothesis is true and we are rejecting it. So that is level of significance. Opposite to level of significance is confidence level. That is 1 minus alpha. So if the alpha is 5%, that is 1 minus 0.05. So confidence level will be 0.95 or it is 95%. Right? Fine?
Yes, ma'am.
Then DF. DF is degrees of freedom.
Degree of freedom, ma'am.
Yes. Yes. Degree of freedom. Meaning is how many degrees or maybe category or variable are independent, right? So that is degrees of freedom. In case of chi-square, generally, when we are reporting the results, we are talking about the degrees of freedom as well, right? Is it clear?
Ma'am, if you don't mind, can you explain degrees of freedom with some example? I always have this question in mind.
For example, suppose we are entering in a bus, right? There are 5 seats vacant
Okay.
and there are 5 people, right?
Mm.
So the person who is at the first from any of the 5 seats, he or she can pick or select the one
Yes.
occupied. Similarly, second, third, fourth. But the 5th person will not be having any option. Whatever
Yes.
is left,
He
he or
has
she
to
needs
take
to
a seat.
occupy that, right? So that
Yes.
is generally we are writing it as n minus 1. That means n minus 1 dimensions are free to take any value. But the 5th, the last one will be always depending upon the remaining.
Okay.
That is degrees of freedom.
Mm.
Fine.
Okay.
Fine. Now, to test our hypothesis, we are using the various statistical tests. And the statistical test can be divided into parametric and non-parametric tests, right? So when we say parametric, test, anyone?
Ma'am, where population is finite and there are some assumption related to population.
Fine. So when we say parametric test, we can say this thing when we are interested to infer the population parameter using sample statistic. It is known as the parametric test. Parameters meaning is what?
Like my mu.
Mean only. Variance, proportion, right? Generally, these are the three parameters generally we are talking about in the statistics. So when we want to say something about the population parameter, like what this will be the mean if the sample mean is so and so, that way we can say we are using the parametric test, right? Now, we can also say when we are considering the normality or when we bother about of data, then we are talking about the parametric test. Generally, in statistics, there are multiple parametric tests available. Some of them are like suppose T, Z, ANOVA, correlation, regression, etc. Right? Next, non-parametric tests. So, non-parametric tests are opposite of the parametric test. We can say when we are not bothering about, when we don't bother about the distribution of underlying population then we are talking about the non-parametric test, or when we are having the categorical data. In such case also we are going for the non-parametric test, or when the assumptions of parametric tests are not met or fulfilled by the data. In such case also we are going for the non-parametric tests, right? Generally, there are multiple types of non-parametric tests are available. Some of them are like chi-square, Mann-Whitney U, then Kruskal-Wallis, Spearman's rank correlation, sign rank test, Wilcoxon sign rank test. So there are multiple tests available, right? Which we can use in the non-parametric test category. Right. So this is the very basic about the hypothesis and the various kind of parametric and non-parametric testing. This is only the thing I discussed here. Further, as today is the day when I talk about the chi-square test. So we are now discussing the chi-square test. Anyone? Any idea about chi-square test?
Test of I think association or test for best fit, something like that.
Very good. So chi-square is a non-parametric test, right? Here we take categorical data and there are variety in the chi-square test. Generally, the first one is the goodness of fit, and second one is test of association or independence of attributes.
Ma'am, one question is there. Somewhere
Yes.
I studied that chi-square is parametric as well as non-parametric, both.
It is correct. When we are
Okay.
considering the chi-square in terms of variance, then chi-square becomes parametric also. So only the one of the statistical tests which is treated or conveying both the categories. But mostly it is a non-parametric test. But means most of the people using the chi-square test as a non-parametric test.
Okay, ma'am.
Yeah. So when I talk about the first category, that is goodness of fit. So goodness of fit is generally we are talking when we are considering or when we are or we are expecting that when we expect the uniform distribution of frequencies. Right? So when we say that the frequencies are equally distributed or almost they are following the same kind of distribution throughout all the categories of the categorical variable, in that case we are using the goodness of fit test, right? So when we are looking for the uniform distribution of the frequencies or oblique count, then we are talking about goodness of fit. In this case, we will be having the one categorical variable with multiple categories, right? Second is independence of attributes.
Ma'am,
Yeah,
can you explain the previous point once again? One categorical variable with multiple categories. I didn't get that.
I think we'll see the examples, so I'll explain you, ma'am. We'll
Okay.
perform the menu using the R, so I'll explain you there.
Okay. Okay.
Yeah. So then next is the independence of attributes. So in this case, we will be having two categorical variables. With their categories. Right. And we want to test that the attributes are independent, rather the attributes are independent. In such case, we are using the second type of chi-square test named as independence of attributes or test of association, or other way around you can also say when we want to test the association between two categorical variables. In such case also we are using the chi-square independence of attributes test, right? Now, if we want to perform all these things manually, so we need to know this thing that what is the chi-square test formula. Generally, I think many of you know this thing. It is sum of O minus E square divided by E. This is the formula. Using that, we are calculating the chi-square, where we are talking about the observed and expected frequency. Yeah. Right. So here we are talking about observed and expected frequency. So as I'll talk about the first, means this is I'm telling you from the manual calculations point of view, because you need to know the concept behind this, because software will give you the value directly, right? So when I say goodness of fit, in case of goodness of fit, Means we always be having the observed frequency, whether it is the independence of attributes or the goodness of fit. In both the cases, we will always be having observed frequencies, and we need to know what is the expected frequency. So in case of goodness of fit, expected frequencies will be equals to average of observed frequency, right? In case of independence of attributes, the expected frequency will be row total into column total divided by grand total. So this is the manual calculation that I told you, because we need to know how to get it, right? Apart from that, when we talk about the independence of attributes, there is one more term we are using, that is contingency table or cross tabulation. So what is the contingency table? Anyone? It is two-way table, meaning one variable you will take in the row with the categories and the second variable you will take in the column with the categories. So it is a two-way table or summary of the data, right? So that means all the frequencies according to the combinations of the categories will be listed in the contingency table, right? So I think this is about the very what I can say, the brief about the chi-square test, which can help us further to perform chi-square test. If I talk about the hypothesis formulation, so in case of goodness of fit, your hypothesis will be there is no significant difference in observed and expected frequencies. Next one is that this is I'm making for the this is for the GOF, that is goodness of fit, right? Now for the independence of attributes. So here we are writing generally there is no association between categorical variable 1 and categorical variable 2, or you can write this hypothesis as categorical variable 1 is independent of categorical variable 2. So this way we can formulate the null hypothesis in case of goodness of fit and independence of attributes. Till here I am clear to everyone?
Yes, ma'am.
Yes.
Yes, ma'am.
Yeah.
Yes,
But
ma'am.
yeah, thank you everyone. Now we will proceed and we'll see how R can help us to perform chi-square test, right? So I'll take firstly, I have given you a file. I'll tell you how to import the file and how to perform chi-square using that data, right? But further, I'll give you some of the examples. Suppose we are having certain vectors available. Using that, if we want to see perform chi-square test, how we can do so, right? So suppose we are having a problem. Suppose we want to check whether the liking of color among people is same, right? So this is our problem. We want to check whether the liking of color among the people is same or not, right? So we need to firstly know, suppose we are giving a, what I can say, we are giving the choices of the color. Suppose 5 color choices we have given. So for this sake of understanding, I am making a vector here, right? Suppose we are asking from the people about this thing. Suppose I have given the 5 choices in the color. I have not executed. I've shown you. Suppose we are asking people among these 5 colors, which color they are liking or which color they are liking most, right? So that way, suppose people are giving their preferences, right? So now I'll make another vector of the frequencies of the that is the observed frequencies, right? Suppose I'm getting 35 for people for black color. I found they are liking the black color. Suppose 24 are liking the white, right? 36 are liking, suppose, the blue color. Then suppose 15 are liking the yellow color, and then again next 20 are liking the purple color. Is it okay?
Yes, ma'am.
May I proceed?
Yes, ma'am.
I'll make certain change for the calculation purpose. I'm making it 10 and suppose making it 25. Now I need to see the sum with 60, 95. Is it okay? Everyone have, I think people have created the same kind of vector like mine.
Yes, ma'am.
Fine. Now, as I said, first thing is, first you need to see this problem is for the goodness of it or for the independence of attributes. So you need to tell me this. Anyone?
Goodness of it.
It's a goodness of it problem.
Yes, ma'am.
Independence of attributes.
Okay. Okay. So may I know why it is independence of attributes? Yes, sir. May I know?
Because of the liking, we want to see that there's no preference about any liking. Everybody likes the same amount for colors.
Okay. Okay. So, sir,
There is only one categorical variable here, so it should be goodness of fit.
yeah. My question was that only I want to ask from Vivek, sir. Sir, we need to firstly see how many variables we are having. So, can you tell me, are you able to understand how many variables are there in the problem? Yes, Vivek, sir.
Yes, ma'am. Only one color. We are talking about only one attribute, that is color.
Color. Fine. Very good. So that means it is a case of goodness of fit and not the independence of attributes. Fine. So if it is clear to us that this is a goodness of fit case, so we will write the hypothesis. So hypothesis will be, there is no significant difference in the observed and expected frequencies of colors or of color variable. Various colors. Is it fine? Hypothesis is okay. Fine.
Ma'am, but we do not have any expected frequencies with us.
Yeah, I haven't performed anything right now. I just
Okay.
only formulated the hypothesis here.
Okay.
Yeah. So, if hypothesis is clear, shall I proceed?
Yes, ma'am.
Yeah. So the next thing is, the ma'am already raised a question for the expected frequency. So we need to have the expected frequency. So here, when we talk about this R software, for the goodness of it, we are using the probabilities for the expected frequency, right? That means, I think we know this thing. As I said, we are looking for the uniform distribution. That means my expectation is what? These frequencies should be same throughout the categories of the color. Yes or no?
Yes, ma'am.
Right. So now you need to see this thing. I think I don't know who has asked me the question. You need to see what I'm saying previously. I think you have asked me regarding this thing. So we are having the observed frequencies, but we are not having the expected frequency. So this is the example which I told you about the goodness of it, right? Now, for the expected frequencies, we will make a vector of the probabilities, right? So the vector of the probabilities will be what? How many categories we are having?
5.
5. So probability for each category will be what?
It will be the same total number divided by 5.
Yes, so it is 1 by 5, 1 by 5, 1 by 5, right?
Yeah.
Yeah, so I can write like this. Or I can write like this as well. Or any other way to write this?
Rep, ma'am. Can we use rep?
Very correct. Right? Done?
Yes, ma'am.
So now we will use the function named as chi sq.test, and you need to pass your variables here. Fine. Yeah, so it should be p equals to probability equals to. Otherwise, it will take it as a y variable, right? So you need to specify it as p equals to. Fine. I hope everyone has got this. Any error, any problem you're facing? Yes. Shall I proceed?
Ma'am, in my case, it is showing X and P must have the same number of elements. I gave 5 itself, but I do not know.
Okay, possible for you to share the screen?
No, ma'am. I am just running it
You can
in
copy
laptop.
and paste in the chat.
This I am doing in my phone. Actually, I am connected in through phone and I am doing work in the laptop.
Okay. So I think it is very similar the way I have written.
Yeah, ma'am. I am just working on it. 1 second. Yeah, same. To enter OBS. I'll check it, ma'am. No problem.
Or you can share, means you cannot share here, or maybe take a pic and drop it in a chat of WhatsApp.
In WhatsApp, can I drop, ma'am?
Yeah. What about others?
Done, ma'am.
Done. Fine. Okay. I think Soumya ma'am has sent. Ma'am, before the, I think it is line number, I don't know, 325 or 326. I think you have put the things as comments. You have put the hashtags.
Oh, okay. Yeah. Acha, okay. Yeah. Correct, ma'am. So it is unable to run. Now I understand.
Yeah.
Yeah. Thank you, ma'am.
Fine. No issues.
Got it.
Got it?
Yes, ma'am. Got it. Thank you.
Now we will see the interpretation part. Chi-squared value coming as 18.88. The degrees of freedom is 4. The p-value is 0.00829. So as a thumb rule, we generally compare the p-value with the level of significance, and by default software works on the 5%, right? Suppose we are assuming now you need to compare your p with the 5%. So what conclusion will draw? That p is less than 0.05, right? So what decision I need to take? Accept or reject the null hypothesis? We will reject the null hypothesis, right? When your p-value is less than your level of significance, you need to reject your null hypothesis. So when we are rejecting the null hypothesis, what we are concluding?
There is a difference in the observed and expected frequencies.
Yes, and the difference is significant. So we can say this thing that we are rejecting the null hypothesis and we are concluding there is a significant difference in the observed and expected frequencies of various colors. Means frequencies are not uniformly distributed. This is the meaning, right?
Yes, ma'am.
Done. So I think it is done. Shall I proceed? I'm writing a problem for you. You please read it. I think you people have read. I'm copying this problem and putting in the chat. So you want, if you wish, you can copy from there. Read it and try to solve it. I think this is much better. I hope you people have read and started working on this. Okay. Okay, Aparna ma'am has sent the answer. Aparna ma'am, have you sent the answer or it was for the previous question? What is your conclusion, Aparna ma'am? Okay. What is the conclusion? We are rejecting the null hypothesis. Fine. So, will you please write what is your alternative hypothesis, ma'am? There is significant difference between observed and expected frequencies. Okay, regarding the absenteeism. Good. What about the others? Everyone is getting the same values like ma'am?
Yes, ma'am.
Fine. So I think it was okay, easy. Shall I proceed for the next? Okay, now we'll talk about the IOA, that is independence of attributes, right? So I think already I told you what is the concept. We will be having the two categorical variable, and we want to see whether the two categorical variables or the two characteristics are independent or not, right? Suppose we want to see whether the smoking habit dependent gender, right? This is the problem we need to solve. Now I'll make a, what I can say, the vector. Is it fine?
Yes, ma'am.
So rather than this, I'll use the rep function, which can help us. Done? Is it fine? I'll make it 36, right? Done? I think clear? I haven't run this. Okay, so done?
Yes, ma'am.
Fine. After this, there is a function called table. This function can help you to make a contingency table. Done. Although when we are using this ref function, so that is why it is showing female 18 females are saying no, and the 0 female are saying yes. Then 5 men are 0 men are saying no for smoking, and 18 are saying yes for smoking. So I think this is not a correct data, but still this way you can understood how to make the contingency table and how to create your vectors. It is fine. Getting? Is it clear? Is it clear, everyone? I hope it is clear. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yeah. So here, can any one of you tell me what will be our conclusion? Anyone? Yes. No. No one is saying anything. What happened?
Gender and smoking habits are independent.
No, no. I am asking here. The in context of the p value, what you will conclude?
Gender and smoking.
Here, your p is less than or greater than?
P is very small,
Yeah, it is less than 0.05.
105.
Yes. So that means you do not.
There is a significant association between
P is
gender and
very
smoking.
small.
Yeah, it is there. So we'll conclude. There is significant association between smoking habit and gender, or vice versa. You can say smoking habit is dependent on gender. Done? Is it okay?
Yes, ma'am.
Fine. Next problem for you. Okay, I think rather than firstly giving you problem, we will firstly see the data importing and all. And I think that way, it's time permits, then I'll give you the problem, right? Now, I think I already shared a file with all of you. I hope everyone is having the same file available in their laptops or desktops, right? Yes? Anyone?
Yes, ma'am.
Yeah. So firstly, I need to set my working directory from where I want to pick the file. So those who are knowing where the file is, there you need to go in your file. You need to go in your file, right? Firstly, Then there you will click on your file, do a right click. And then using the properties, you will get the location of your file. So you need to copy that location. Okay. Getting me?
Yes, ma'am.
Everyone knows, I think, how to copy the location of the file. Fine. And then you need to copy. And then what I'm doing, this you need to do. No, not, I think it is enough. Done? How many of you have copied the path? Done? Yes. Say anything, anyone, anything. Is it okay or not? I think everyone is knowing how to get this path. Yes or no? Please say something. How I will know this thing, whether you're
I
getting.
think I missed out whether, I mean, I don't know that that data will be used here and I need to copy it into my desktop. I'm doing it now. So I'm opening WhatsApp web and doing it.
Okay, fine. What about the remaining people? Are you able to get the location of your file? You need to copy that location. Coming in the R using setwd, that is set working directory function, inside the double quote, you need to copy and paste that location. Okay. Done?
Ma'am, how to copy the location?
You are on the file, do the right
Yeah.
click.
Okay.
Go to the properties.
Properties.
Our dialog box will appear.
Yes.
There you can find location will be written
Ah.
somewhere. Copy
Oh.
that.
Okay. Okay, ma'am.
Yeah. Then come in the R using the setwd under the double quote. You need to paste that location with whatever you have copied. And before running it, you need to check if there are backward slashes. So you need to convert single backward into the double. Or you, yeah,
Okay.
otherwise it is giving error to you. Or you can put the single forward or forwarded slash. So you can replace the double backward slashes by the single forward slash. That will also work for you.
Okay.
So I think now the library is set from where we want to pick the file. So shall I?
Ma'am, how do I know that it is executed?
Are you getting any error in the console?
There is no error. As such, there is nothing that is appearing in the console also.
I think same should be same should appear, the whatever you have executed.
Okay, as it is, yeah. If that is appearing, it's fine, ma'am.
Yeah, and after that we are getting a new line. That means it is executed.
Okay. At the end, I did not put any forward slash or backward.
That is up to your location. I don't know what is your location.
Okay, okay. There is nothing in the location, so I did not mark anything, right?
So whatever you copied, you need to put exactly the same.
Okay, okay, ma'am.
Ma'am, I have got an error. It says cannot change working directory.
Okay. What you have written, sir? Possible for you to share?
Yeah, ma'am, I'll share it.
Just a minute. I'll stop share my screen.
Can I just put it on the chat?
Up to you.
Just. This is what I have.
So your file in the C drive,
Yeah.
can you remove from the C drive
Okay.
and put it somewhere else?
Okay, ma'am. I'll do that.
Yeah. Now we will use read.csv, sir, because firstly you need to set the location from where you want to pick the file. After that, we are using this function to picking the file.
Okay, ma'am. I think I had loaded it in D drive.
Okay. Now copy the location.
Okay, ma'am. And do I need to put in double slashes everywhere?
If it is backward, then double. Problem resolved.
Just a moment, ma'am. Yes, ma'am.
Fine. So I think I can share my screen now.
Yes, ma'am.
Fine. So if problem resolved, after this, we need to bring our data here. We need to pick the data from that location, right? So the file which I shared with you, it is a CSV file, right? So I am storing the file into the data object. So I have written data and then I have given the assignment sign. Now I'm using the read.csv function, right? You need to use this function. In the bracket, in the double quote, you need to copy the name of your file and you need to paste it. So I'll suggest, rather than typing, please copy and paste the name so that it will not give you any error, right? I think I did, and you can see in the environment it is showing me the data object has created 20 observations and 4 variables are available, and then when I'll click on this table, I can see the preview as well, right? Is it okay? Shall I proceed? Till 800, I think line number 800. Till here, everything is clear to everyone. Shall I proceed?
Yes, ma'am.
Fine. After that, I used a function called is.factor. I want to check because there are 4 variables available in your sheet, in your file. You can see the ID. ID is nothing but it's an identity number. So I think it is not a variable. Apart from this, we are having gender, pet owner, and the education. So we are having certain labels here, right? So gender, 1 is for the male, 2 is for the female. So this is the data which I have created. So I know this thing. I labeled 1 for the male and 2 for the female. 0 for the no pet ownership, 1 for the pet ownership, right? So this is what I have used here. Coming in this, I want to check, because if you can recall, previously I told you to create a categorical data or categorical variable, we need to use the factor function, right? So I'm checking is dot factor means whether the gender is a factor. This is what I want to check. Similarly, whether the pet owner is a factor. So both I have run and I got false. Is it okay? That means both are not the categorical data. If you wish to convert them, how you can do? Fine. And if you want to give the label, you can write yes and no. I need to check. Is it clear what I'm doing here? Is it clear, everyone?
Yes.
The second one I didn't understand, ma'am. Pet
Which
owner, yes, levels I didn't understand.
Okay, I think rather don't use labels here because we have already coded the data in Excel. So go with this only. That is working. Let's go with this. Why it is taking any? Data is available, I think. Oh, data is not available. Give me a second. We made a mistake somewhere. I'll read the data again. I want to see the data. So I think firstly I'm keeping it on hold. We are not converting them because it will not change our results also. So I'm keeping it hold, right? Moving ahead firstly. And then here I want to check a hypothesis. My hypothesis is pet ownership is independent of gender. Right?
Excuse me, ma'am.
Yes.
I got it true, ma'am. I was able to run the previous two statements.
Which one?
Is the data gender is now entered into factor, and pet owner is also entered into factor. And when I try to retrieve the data and then check is dot factor data gender, it is changed to true now.
Fine. Good. I made some mistake here. Is it something?
Again, the same problem, ma'am, as I did hashtags. Yes,
Sorry?
you have put a hashtag before
No,
this.
I have kept afterwards because I said I'm keeping it on hold.
Acha, okay.
Yeah.
I did the same thing, ma'am.
Give me a second. I think we'll do afterwards. Okay, sister, you did, so I'll also check. Let me check. Fine, it is working now. It is working now. Fine. So it is now we have done this. This is our hypothesis. Now we need to see if you want to get a table, if you want to see the contingency table, you can use a table function, right? Inside this, I'm using data dollar gender, comma, sorry, dollar gender, comma, data dollar pattern. This is the way we are getting the values. So 1 and 2, that is male and female. 0 and pet ownership is no, pet ownership is yes. So male, 5 male are saying they are not owning any pet. 1 means 5 are saying they are owning the pet. Similarly, female, 8 women are saying, or 8 females are saying they are not owning the pet, but 2 are saying they are owning the pet. This is the meaning, right? Now to perform chi-square, we'll use the same function, right? And then you need to give your variables. Done?
Ma'am, the order is okay. Can we put it in either ways? Pet owner first, gender next. Okay.
Yes. Fine. Is it done?
Ma'am, I got an error.
Okay.
And it says chi-squared approximation may be incorrect.
Okay. It is not an error, it's a warning, ma'am, that you can
It's warning. Yeah. Warning message.
that you can skip, no issues.
Oh, okay.
Yeah. So you can see we are getting the chi-square value, we are getting the p value. So anyone who can tell me what we will do here after getting these results, what will be the conclusion?
The p-value is greater than 0.05.
Yes.
0.05.
So we will hold the null hypothesis, right?
Yeah.
So we'll hold the null hypothesis, meaning is what we are saying, that ownership is independent of gender. That means there's nothing to say or nothing to comment that pet ownership is depending upon the gender. Whether a person is male or female, they can own the pet, right? Is it fine?
I've got the same answer.
Okay, fine. So now the problem or the question for you. In the same sheet, we are having other variable also available, that is education. So now you need to check whether the pet ownership is dependent on education or not. Whether education is playing any role to own a pet or not. Right? I hope you got the question.
Ma'am, can I get the WhatsApp link?
I think you need to talk to or ask to the yoga sir in a group. Maybe he'll available in the meeting. You need to ask to him.
Yes, ma'am.
So if yoga sir is available in a meeting, I request please share the WhatsApp chat link. I hope you are performing. Very quick. Good Aparna, ma'am. So please write your conclusion as well.
Pet ownership is independent of education, ma'am. H0 is accepted. Because p-value is 0.1924.
Yes. Correct. I hope everyone got it. Yes. Means education is not playing any role in deciding the pet ownership. Is it so, right? Correct, Sainath sir. Same values also, you are also getting the same. What about the remaining people? It is done. Is it done, friends?
Yes, ma'am.
Fine. So I'll give you a problem. For that, you need to create vectors and need to make your hypothesis and check it. Whether the voting preference is dependent on gender. This is the problem you need to solve. You can take voting preferences and you can take gender variable. These two vectors you can create. Means you can assume, suppose there are three parties, what I can say political parties, and then you need to decide that whether male is giving vote to one particular party or not, something like that. You need to assume in that way.
Excuse me, ma'am.
Yes, ma'am.
I'm still not confident in creating vector.
Why?
I'm not sure because I still unable to. I mean, voting preference. For example, VOT P I name it and then I put a vector in it and C of what should I write within is a question mark still.
I said, I have told you, you need to assume there are three parties. Any party, suppose A, B, C, three parties you can create, and you can create a vector.
Values into it. Where do I enter?
You do not need to use, no. You can see the previous example I have taken here of gender and the smoking habits.
Mm-hmm.
So you need to create the multiple times MF, or maybe the three parties, you need to repeat it. And
Okay.
that way, once you will use the table, this will give you the count for that. For which particular category, what is the count of M and F or something like that. It will do that for you.
Okay.
Done. Okay. So how many elements were there? I have made a mistake here. Length out. Fine.
Ma'am, should there be a logic between this counts 15, 30?
Obviously, if I'm creating this vector for the 30, means length of means total 30 elements will be there by repeating VC, right? So you can see I have run this VP. Just a minute.
So that means 15 are male and 15 are female in the respondents.
Yes.
And their options are varying between ABC.
ABC, yes.
Okay, okay.
So the vector length should be same. Right?
Yes.
Anyone who got the answer? So I think it is very predictable because we were getting all the observed frequencies as
P-value is 1, ma'am.
yes, p-value is 1. That means we are going to hold the null hypothesis, right? That means voting preference is not depending on the gender. It is independent of gender.
Yes, ma'am. Understood.
Yeah. What about others? Ma'am, now the next problem I have written. This is the last problem for the day. You can
Yeah,
read.
I'll do it, ma'am.
Online shopping is dependent on gender. So yes, no vector need to create here for online shopping.
Yeah.
And gender.
And gender will be male, female.
Yeah. Or I think I'll tell you this way also, because in both the cases I have used the web function. So you can write or you can create your vector like this also. It is not mandatory. Getting me?
Yes, ma'am.
So 21 is the length. Similarly, you need to create a second vector for online shopping. OS I have written here. And then similarly, you can type here yes, no, yes, no, yes, no, whatever you want. Somewhere I have made a mistake. Yes. Great. It is 21. Unknowingly, I created 21 elements. So this way also you can go. It is not right. Like you can copy. You need to follow. Means like what is the sequence I have given to the MF and yes, no, according to your own opinion, according to your own understanding, whatever the sequence you want to keep, you can keep. And then using the table, you can see the observed in the sorry, you can see the observed frequency count. This is the count. Done. So in my case, I have made this. I think I am waiting for your answers. I have given you the direction. Probably this will help you out. Okay. Saira sir, you have written this these values for the online shopping question or for the previous one? That is the voting preference. For which question you have written these figures? Previous one. Fine. That means you are going to hold the null hypothesis, accept the null hypothesis.
Ma'am, gender and OS, in my case, it is p-value 0.14.
Okay, fine. That means you are again holding or keeping or going with your null hypothesis, right?
Yes. Yes.
Fine. What about others? I hope everyone is able to cope up and understood what I did today. Any responses?
Yes, ma'am.
Okay, got it, sir. What about the Aparna ma'am? I think yours is also done, right? Cyrus sir has shown a thumbs up. Okay, Anup sir has also sent a value here. Fine, good. So I think we can say this thing. It is clear to every one of you today. What I
Yes,
discussed.
ma'am. Yes, ma'am.
Fine. So if it is clear, so I think this is all from my side for the day. Now, if you are having any queries, any questions, so the platform is open for the same, or else we can wind up the meeting for the day and meeting tomorrow.
Ma'am, not a doubt, but a feedback point. Today the session is too interesting and learning, full of learning. Thank you. Because the other day I was totally lost.
That was not your domain. Na?
Sorry, that is not my cup of tea. I was slow in that aspect.
Fine. Good. If you have enjoyed it, it's good. Means purpose has solved.
I don't want to give up, ma'am. So again, I am trying on it.
That is very commendable. Very commendable. We have such kind of attitude. Only then we can learn, I think.
Thank you, ma'am.
Thank you, everyone. Thank you so much, ma'am.
Thank you, ma'am.
Yeah. Anup sir, any question?
No, ma'am.
Fine. So can we call off our meeting for the day?
Yes, ma'am.
Yes, ma'am.
Fine.
Good night, ma'am.
Good night, Soumya ma'am. Good night, everyone. We'll meet tomorrow and discuss the next statistical test using the R programming, right? So take care. Till then, we'll meeting tomorrow online. Yogra sir, over to you. I think we are done for the day. Yogra sir, are you there? Yogra sir, are you there? Okay, friends, I think we can leave the meeting. Maybe sir is busy on call or maybe in some other meeting. So we can leave the meeting, right? Meeting tomorrow. Good night, everyone. Take care.